Welcome students to the chemistry class. Today I will be taking up electrochemistry chapter. This is very important chapter in the point of view of NEET exam. Today in that chapter I will be taking up two topics. One is electrolytic conductance and the other one is Faraday's laws. These are very important topics. Please listen attentively. See, first I will take up electrolytic conductance. Here there is electrolytic cell and these are the electrodes. The distance between the electrodes is, let's say, L, and the area of cross section is A. Then L by A is called cell constant, and cell constant into 1 by R is equal to 1 by rho, where 1 by R is called conductance of electrolytic cell and 1 by rho is called specific conductance, also called conductivity of the electrolytic cell. These terminologies are important because in the examination they don't mention R is this, rho is this. They will mention conductance is this, electrolyte and specific conductance value is this, like that they will mention. So you have to aware of these terminologies. Molar conductance. Molar conductance means the conductance of 1 mole of an electrolyte in a solution, which is notation is lambda m is equal to specific conductance denoted by K kappa into volume, that is equal to K into 1000 by molarity. So remember this formula to calculate the molar conductance of the electrolytic cell. Now a few more points you be aware. When you dilute the electrolytic solution, that means if you add large amount of water and you are diluting the solution, what happens? Concentration decreases when you dilute. So on dilution, that is when concentration decreases, what happens to molar conductance? It increases, whereas specific conductance decreases. There is a reason for it, but just remember that molar conductance and specific conductance, they vary oppositely when you dilute. And for both are both strong and weak electrolytes, for both this is the scenario. And degree of dissociation, when a weak electrolyte is dissociating, let's say degree of dissociation is alpha. What is the relationship between alpha and the molar conductance? This is the relation. Molar conductance is equal to alpha into lambda m naught. Lambda m naught is the molar conductance at infinite dilution scenario. Means when you add water infinitely, large amount. In that case, what is the molar conductance? That is denoted by lambda m naught. Whenever in this chapter electrochemistry, whenever you come across words like degree of dissociation, percentage of dissociation, you must apply this equation. Lambda m is equal to lambda m naught into alpha, where lambda m naught is the molar conductance at infinite dilution, also called limiting molar conductance. Okay. Now let's see problems on this. See, there are three solutions A, B, C. Assuming three solutions have same specific conductivity, find order of molar conductance. See, we know that just now we have seen the formula lambda m is equal to 1000 K by concentration. When specific conductance K is same for all three, lambda m and C, they are inversely related. Therefore, lower the concentration, higher the molar conductance. Higher the concentration, lower the molar conductance. So C is the low and A is the high. So if you see the options, A greater than, B greater than, C. Specific conductance of salt of 0.01 molarity concentration is 1.06 into 10 power minus 4. Specific conductance, that means K, kappa value is given. Lambda m is how much? Now see, so lambda m is equal to 1000 into specific conductance is 1.06 into 10 power minus 4 divided by concentration. Concentration is 0.01 molarity. That means I can write it as 10 power minus 2, 0.01. So if I cancel this 10 power minus 2 here, I can write 10 power minus 2 and 10 power minus 2 and 2 zeros I can cancel and you will get 10.6 here. Look at the next question. 0.1 molarity solution of electrolyte AB placed in a conductivity cell with electrodes 4 centimeters apart. Electrodes are 4 centimeters apart and each with area of cross section 2 square centimeters. Was found to have a resistance of 200. Find molar conductivity of the solution in terms of centimeter square mole inverse and in terms of meter square mole inverse. Well, they may ask anything among this. Now lambda is equal to 1000 K by m. We know this formula. Now substitute the K value. K value is 1 by R into L by A. Resistance is given, L is given, A is given in the question. So 1 by R into L by A, that is the K, and divided by molarity. Molarity is also given in the question. In the beginning only 0.1 molarity. So by substituting resistance L and A and concentration, you will get answer as 100 ohm inverse centimeter square mole inverse. Now, what about the second one? When they ask in terms of meter square, then just do like this only. Then you will get answer in the CGS unit, because if you see here all are in square centimeters, length is also in centimeters. So you will get answer in centimeters square. And when they ask question in meter square, then what you do, just in this answer, see, look at the centimeter. In place of centimeter, you put 1 centimeter is equal to 10 power minus 2 meters. Just substitute in place of that centimeter. Rest everything as it is same. So 10 power minus 2 square means 10 power minus 4. 10 power minus 4 into 100 is 10 power minus 2 ohm inverse meter square mole inverse. This is the answer in terms of meter square. Like that you have to do. Next question. This is the application of Kohlraasch's law. Lambda m naught, that means limiting molar conductances of 3 compounds are given. Barium hydroxide, barium chloride, ammonium chloride. Find lambda m naught of NH4OH. See the procedure here. Saying whatever is asked, lambda and NH4OH, this is asked in the question. Just write this compound. Now here there are 2 ions are there in this, NH4 plus and OH minus. 2 ions are there in this compound. So what you do, where is this NH4 plus in the given data? Look there. It is present in the NH4Cl. Write that compound directly, NH4Cl. Next, where is this OH in the given data? You look. It is there in the barium hydroxide. Write directly, barium hydroxide. So I got NH4, I got OH. But I need only one OH. But here in barium hydroxide there are 2 OH. So what I will do, I will multiply with half, so that I will get only 1 OH in this. Now in this process I got NH4 plus and OH, but unnecessarily I got Cl minus and half barium. So barium and chlorine I need to subtract. So where are this barium and chlorine? It is in the second data, BaCl2. So subtract the BaCl2. But 1 Cl I have to subtract, half barium I have to subtract. Whereas in this BaCl2, 1 Ba and 2 Cls are there. So what I will do, I will multiply with half, just like this. Then substitute the given data in the place of this NH4Cl, etc. For example, NH4Cl, if you see what is the value, 129.8 plus half into barium hydroxide data 457 minus half into barium chloride is 240.6. Then you have to just multiply and add. That's it. So these models, this is how you have to follow to get the answer quickly. Let's see the next question. Specific conductivity is highest for. See, in the beginning slides only we have seen when you dilute. Dilution means what? On dilution what happens? Concentration or molarity decreases. When concentration decreases, we have seen lambda m increases whereas K decreases. So here they are saying specific conductance, that means K is highest for which one? So K is highest. K and concentration, they are proportional. If K is more, concentration is more, then K will be more for that. So we need highest K, that means highest concentration is the answer for this. Suppose if they ask molar conductance, opposite. See, lower concentration has highest molar conductance. So that means molar conductance if they ask, then fourth one will be the answer. This is HCl. This will be the answer in that case. Lambda m is highest for. So lambda m is highest for the lowest concentration compound, that is 0.0001 HCl. Next, molar conductivity of acetic acid at infinite dilution means lambda m naught is given as 390.7, and for 0.01 molarity for this concentration acetic acid, lambda m is given as 3.907. So lambda m is given 3.907 and lambda m naught is also given 390.7. And what they are asking? They are asking alpha, means degree of dissociation, and the pH of this acid. Now we know that alpha is equal to lambda m by lambda m naught. In the beginning slides only we have seen this formula. So 3.907 by 390.7. So if you see this 10 power minus 2. So that means 0.01 is the alpha. And what about pH? How to get pH of acetic acid? In ionic equilibrium chapter, you must have studied this. When acetic acid is dissociating into acetate and H plus, the H plus concentration is equal to C alpha. This is the formula. So here C is given as 0.01. Alpha just now we got, that is also 0.01. We got alpha as. So 0.01 into 0.01 will be 10 power minus 4. So pH will be how much? pH will be 4 for this. So 0.01 is the alpha and 4 is the pH. Now let's look at some questions on the Faraday's laws. But before going into the questions, let's briefly see the formulas and important points so that we can understand these questions quickly. See, Faraday's laws, actually when we have to apply the Faraday's laws, when in the question, when they are asking calculate the amount of the species produced at cathode or anode, how much quantity is producing at the electrodes. If that is asked in the question, apply the Faraday's laws. Remember, you must apply the Faraday's laws in that case. Now, what are the formulas in this? See, W means weight. This W is the mass of the substance deposited at the electrodes is equal to E. E means equivalent weight of that substance into Q. Q means charge divided by 96,500. That is the charge of 1 mole of electrons. W by E, when you bring this E left side, W by E is equal to Q by this. W by E can be written as equivalence or moles into N factor. Also you can write. So remember this formula, moles into N factor is equal to Q by 96,500. Now this Q by 96,500 is also equal to number of moles of electrons, which is also equal to number of Faradays of charge. Suppose if they give 2 Faraday charge, just substitute 2 Faraday here is equal to moles into N factor or Q by 96,500. Now in a given electrolytic cell, same charge is involved at the cathode side and anode side. Since same number of electrons transport from anode to cathode, charge involved is same. Therefore, Q is same in both cathode and anode. When Q is same, then moles into N factor for cathode substance, depositing substance, and the substance depositing at anode will be same only, always. Next, equivalent weight. How to get equivalent weight? So if they ask molar mass by N factor, and we will see briefly what is that N factor, how to get. N factor actual definition is moles of electrons involved per mole of species. So important N factors you keep in mind. Mostly questions involve either metals or halogens, oxygen, hydrogen. So if you remember this, you will answer, you will substitute the N factor quickly and arrive at the answers. But what is the basic definition of N factor? Number of moles of electrons involved per mole of species. This is applicable everywhere. But for metals, that N factor is nothing but valency or its ionic charge. For example, Al plus 3 is its N factor. Cu plus 2, Ag plus 1. These are the N factors of these metals. And for halogens, N factor, take it as 2, and hydrogen producing from water, N factor is 2. For oxygen, N factor is 4. These 4 are very important cases, remember them. Let's see the questions on this Faraday's laws. 2 Faraday charge pass through solutions of 3 salts. Find molar ratio of metals deposited at the respective electrodes. So they are asking molar ratio. Now we know that moles into N factor is equal to number of Faradays of charge. Here you see 2 Faradays of charge is passed for all the cases. So therefore in all the three cases, moles into N factor is 2. Then moles of substance will be 2 by N factor. So in the case of first, what is the metal? Ag, copper, third one gold. So moles of Ag is to moles of copper is to moles of gold. They are asking this in the question, which is equal to 2 by, moles means 2 by N factor. And what is the charge of silver? Plus 1. So N factor is 1 and N factor of copper is 2. N factor of gold is 3, as you see Au plus 3 here. So that means 1 by 1, 1 by 2, 1 by 3. That is not there anywhere in the options if you see. So what we will do, we will multiply the whole ratio with 6. Then 6 into 1 is 6. 6 into 1 by 2, 3. 6 into 1 by 3, 2. So this is the answer for this. Next, molten NaCl is electrolyzed using 9.65 amperes for 2 minutes. Find mass of Na produced at electrode, assuming current efficiency is 50%. That means all the charge is not utilized, only 50% of charge is utilized. That is the meaning of the current efficiency. Now, so we know that moles into N factor of substance depositing is equal to Q. I can write Q as current into time in seconds. So I into T by 96500. Moles of Na is equal 9.65 is the ampere given in the question, and 2 minutes. 2 minutes means how many seconds? 2 into 60, that is the seconds. Current efficiency, because not all charge is utilized, only 50% is utilized. So 50 by 100. Now if you calculate this, simplify this, then you will get moles of Na as 6 into 10 power minus 3. Then, but in the question they are not asking moles, they are asking mass. So how to convert moles into mass? Mass is equal to moles into molar mass of the substance. We want mass of sodium, so molar mass of sodium into, moles of sodium into molar mass of sodium. That is the answer. Let's see the next one. In electrolysis of water, find molar ratio of H2 and O2 at the respective electrodes. Now see, we know that again moles into N factor is the charge. Now when you are electrolyzing water, same charge is involved at cathode and same charge is involved in at the anode for the deposition of H2 and O2. So therefore, moles into N factor will be equal for cathode, that means cathode side, anode side also moles into N factor must be equal. Now, cathode side what will deposit? Hydrogen, anode side oxygen. So, moles of hydrogen by moles of oxygen is equal to N factor of oxygen by N factor of hydrogen. Now N factor of oxygen is 4, I told you to remember this, and N factor of hydrogen is 2, therefore answer is 2:1. Next, density of copper is 8 gram per centimeter cube. Number of coulombs required to plate an area of 10 centimeter into 10 centimeter. Area is 10 centimeter of the plate on both the sides to a thickness of 10 power minus 2 centimeters using copper sulfate solution as electrolyte. See, there is a plate, area is given, but they are not coating on one side, they are coating on both the sides. So, with what substance they are coating? They are coating with the metal copper. And now see, what is the charge involved? We need to calculate what is the charge in terms of coulombs. First we will see what is the mass of copper depositing in total. Then convert that mass into moles of copper. Moles into N factor is equal to Q by 96500. By using that we can get the charge. So first point is finding the mass of the copper. How we will get mass of copper depositing? See here, first let's find out the volume. How much volume is required to coat with the copper? Volume is equal to area into thickness. So plate area we know. So area is how much? 10 centimeter into 10 centimeter, and thickness also given as 10 power minus 2. This is the on one side how much thickness you have to coat? 1 centimeter cube. But both sides you are coating, therefore total volume of copper is 2 centimeter cube, 1 plus 1. Now mass of copper required is density into volume. Density is equal, since mass by volume, density into volume, and volume is 2 and density is given 8 gram per cc. So multiply with that, you will get mass. And molar mass of copper is important to remember. Sometimes they may not give in the question. Molar mass of copper is 63.5. So mass by molar mass will give you moles. So let's apply this formula now. Moles into N factor is equal Q by 96500. Mass of copper is 16. Molar mass is 63.5. So this is the moles. Moles into N factor. N factor of copper is 2 because Cu plus 2 state. So this is the N factor is equal to Q by 96500. By simplifying this, we will get Q approximately as 48250 coulombs. These are the important models of the Faraday's laws. If you see in most of the models, if you see in very important formula, moles into n factor is equal Q by 96500 is equal number of Faradays of charge. If you remember the single formula, most of the Faraday's laws problems you can solve using this. And n factor, remember, for metals n factor is just the charge, you take the charge. And water electrolysis, hydrogen case n factor 2, oxygen case 4. So by using this, you can get most of the problems. That's it. I hope you understand all these concepts. Thank you.